All right, I'd like to welcome everyone to the 967th monthly meeting of ATMoB. Our guest speakers will be Qijia Zhou and Kane Sjoberg. They'll be talking about the NASA Eclipse Ambassador Program. And with that, we'll have our sort of typical agenda, nothing atypical here. This seems like a Glenn slide.
It does.
You know it's time to run when you see that.
Which one is Glenn?
So
Glenn's in front.
No, Glenn's still in the observatory. He can't move his old ass anymore, so.
this down button works if it's easier.
Okay.
And there's a laser. Want to point stuff out.
Not for the folks at home.
If I could just say two more things about the mirror grinding. I'm having great difficulty finding plate glass tools. They're actually very difficult to find. And so we may, there's one other place I need to check. We may have to use dental stone tools. Phil Rounsville tells me that even up at Stellafane, they're trying to move away from dental stone because of the risk of contamination. All it takes is one little piece of 120 grit to be hiding until you're at 5 micron grit. And that can cause some big problems, but we're working on that, so we'll see how that all goes. Other than that, I think we're in pretty good shape with the mirror grinding stuff, so, yes, sir.
Can't we just go to a glass outfit and have them cut some blanks out?
I talked to a buddy of mine who owns Country Glass in Hudson, and he said we'd have to go to a specialty place. It's rare to find glass that thick. But he said that's what he suggested. I don't want to go to the trouble of, somebody suggested, go to thrift stores, look for big, thick glass coffee tables, and then cut your discs out yourself. You want something at least 3/4 of an inch thick. And I don't, that's a project I don't want to get involved in at this point. If we can get, I've used the tile tools before, the dental stone tools, without any incident. You just have to be careful and clean them. So, but we'll see, we're getting there, So this is Gargulon, you got the cartoon now. God, you got the, or shall we move on?
Yeah, we go on,
You
yeah.
think people have soaked this in enough?
I know we need, Sal needs a little extra
You know,
time.
there was an asteroid, a school bus-sized asteroid passed by the planet this morning. See? There was nobody running. All right, down arrow works. Here we go.
Okay, top 5 signs an amateur astronomer is getting old. Number 5, the 16-inch primary adjusts to the outside temperature before they do. Number 4, Uriah Nebula, was it IC42, NGC42, or M42? Number 3, more and more objects appear to be faint fuzzies. Number 2, star images suffer from astigmatism, but the telescope's optics are just fine. And the number 1 sign an amateur astronomer is getting old is they're downsizing their scope so they can still carry it out of the garage.
Oh, man.
Yeah.
That hurt.
It does hurt.
It does hurt. It hurts for a few days afterwards.
Okay.
Well, I wanted to outline the upcoming weekends for Clubhouse duty. So there they are. You'll see those in the newsletter, and you'll see them on the event calendar as well. These are the Dark of the Moon weekends where we have people on duty, weather permitting, to open and close the clubhouse on those evenings. We're still looking for somebody to volunteer for October 13th, but I'm not sure if the weather's gonna help us out tomorrow night. As a matter of fact, I'm not sure the weather's gonna help us out Saturday for the eclipse either, because that was my first slide to remind you that this Saturday, we're in store for a partial solar eclipse of the sun. I know a few of the club members have journeyed off to the southwest to be in the path of annularity. And there it is. I mean, you can see it runs from here to here. And even some of the long-range cloud outlooks really only show clear skies in here. We'll see. If you do choose to observe it, there are no outreach events in the Boston area for this eclipse. But what I would ask is that you at least, if it's clear, break out your family, make them look at at the eclipse, show it to your neighbors or friends. And so you can do a little one person outreach with that. Just remember, safe solar viewing, right? We all know it. We all know what to do, right? Yeah, be careful. Eclipse glasses. Eileen's got them. They're going fast. They're selling like hotcakes. See, door prices. The planet roundup, Saturn transit is about 8 o'clock. Have any of you been out looking at Saturn lately? The ring tilt this month is about 10 degrees. And if the air is steady, in the fall in the New England, I think the air is some of the steadiest air we get. See if you can spot the Cassini division. With a ring tilt of only 10 degrees, the air has to be really steady, and you'll be able to see it out on the out at the onset of the rings.
Another thing is, when the rings are edge on like that, it's a good time to see some of the fainter Saturn's moons.
Because the rings actually contribute quite a bit of brightness to the
Yes.
planet, yeah. Jupiter reaches opposition on November 3rd at magnitude -2.9. Here's a project for you if you've never done it before. The Galilean satellites are actually disks. They're not little dots of infinitely small points of light. They're actually physical worlds that have a substantial enough size that even from 400 million miles or so, they present disks that Io is about 1.3 arc seconds, Europa is a little smaller, Ganymedes at 1.8, and Callisto is at 1.7. And then also note the color and the albedo, the reflectivity of each of the moons. Especially pay attention to Callisto. Callisto is a very dark body. I think its albedo is around 30%. There are no Callisto transits taking place right now, but when they start to happen again, I'll call your attention to them because it's amazing how dark Callisto looks when it's silhouetted against the bright clouds of Jupiter. So that's something to look forward to down the road a little bit. Neptune, of course, is still out there at magnitude almost 8. Uranus rises with Jupiter at magnitude 5.7. If you get up nice and early in the morning, Venus is shining at magnitude -4.5, 28 arc seconds, the big fat crescent. Try for daytime observing. I got a peek at the moon this morning, a whisper-thin crescent in the east this morning. So I'm not sure we'll see it tomorrow, but it was very pretty this morning. So anyway, hopefully these are things that will inspire you to go out and actually do some observing. The variable star of the month, Glenn's favorite variable star is SS Cygni. It's a cataclysmic variable where, now correct me if I'm wrong, it's a binary system where one star is siphoning off material from the other onto an accretion disk. And the light variations happen because of the accretion disk events.
There's an outburst from the surface of the the white dwarf itself.
At the accretion disk, right? And so this runs with a period of about 30 to 50 days. And did you just say it's an outburst now?
Just passed one. We were
Just
looking,
passed.
I put out a little alert, I think, said check this thing out because it happened any time, and it did while it was cloudy. So now it's already back down again. And the next one would be
Soon.
in about 50 days. So I know this particular part of the sky is still visible. I've been looking at SS Cygni through about February, mid-February. So there is time to catch another one of the outbursts.
Glenn, when you said it just happened, you mean in October?
Just this last week or two or so.
Oh, okay. So this only goes out to 10/1.
Yeah.
So this is the stuff you can get on the AAVSO website. You can just give you some idea what the pattern is like. And of course, you can see this is the part of the year when observations are, This is the part of the year when observations are tough because it's, basically not up in the nighttime sky. Right, is that right? Did I get that right? Yeah.
Yeah, what's the problem lately is, especially if you're doing star hopping, is that part of Cygnus is almost straight overhead. And with the Dobsonian mounted telescope, it's really a struggle. I know I was checking it out myself just about 2 weeks ago, and my back had been giving me trouble, and that hurts when you gotta get down on the ground like this, and then go like this to look up the tube of the finder scope. I'll ignore that, it's just the president, he's always bugging me.
You tell him never to call you here.
Never call him.
So while Glenn's ignoring his phone call, there is a way to stop that. You can just push one of the buttons.
Well, by the time I find that, it'll be done anyway.
All right. So the double star I wanted to suggest to you this month is an easy one. It's a famous one. ATMoB is Beta Andromeda.
It was Biden, well.
He's telling you to turn off your phone.
So this is an easy star to find. It's a very lovely sort of a gold and blue double star that I think you really enjoyed. If you haven't seen it in a while, if you've never looked at it, it's really well placed for viewing these days. 9.4 arc seconds is pretty easy to split, and the colors are really quite beautiful. So
It is a beauty. In fact, Alberio, those of you who know much about double stars, Alberio tends to get the top number as far as the most popular double star in the sky. Alberio is gold and blue as well, but with Alberio, the separation is about 32 arc seconds. This one, Rich mentioned, it's about 10 arc seconds, so they're a lot closer together. And what's neat, they used to have a 6-inch telescope at the Oak Ridge Observatory out in Harvard, Mass, and I used to have use of that particular telescope. And back sometime in the 1970s, This thing was easy to split, but that star right there, the blue star, looked a little bit wide, it looked long. It turns out it's a very tight binary system. The maximum separation is about a half an arc second. I just happened to catch it when it was at its widest separation. So that's a great system to look at. Again, the colors are beautiful, and it's a very easy star to locate.
So I'll try to do this every month, pick a really nice double star to try to inspire folks to get out and do some observing.
And this is, again, you can see this with a 2-inch, 60mm refractor, 2.4-inch refractor.
Yep.
Any small, and if you're doing star parties, this is a great one to show the public because, again, those colors are just so striking.
Yeah, you're right. That's a beauty. So don't forget about that. And you can always hop over to Andromeda right here, or M76, the little double right there. And I don't know if you folks have ever played it. This is Meroc. NGC 404, the ghost of Meroc, is an elliptical galaxy. I think it's an elliptical galaxy that's sitting right in the same star field as Meroc. And it's often overlooked, but it's probably one of the most commonly reported things that aren't a comet, but reported as a comet, because it sure looks cometary when you look at it.
And almost off the picture, by the way, another one of my favorites, the Aries Gamma right down here. That's a gorgeous double star. They're both about 4.5, so it's a twin system. They're both A-type stars, so they're both white. And I think the separation there is about 10 arc seconds as well. So you can always check out these two first and notice the white colors, and then go to this one and notice the gold and blue. And it's really, anybody that thinks stars are all white, that's kind of a surprise to them.
Yep, and the reason I mentioned NGC 404 is because from light polluted areas, you'd be hard pressed to find that galaxy. But guess what? Double stars, you can see those on any night from anywhere. So it's if you live in a light polluted area and the sky's killing you, you can go back and look at some of these beautiful double stars. They're really fun to look at. Yes, sir.
I saw a cool story about Meroc, by the way, that there's Meroc, there's Meroc's ghost, and apparently some random amateur astronomer was doing a 30-hour-long exposure in near Meroc, and then found another galaxy right next to it, and got a scientific paper published.
Nice.
And named it Meroc's Goblin to...
Well, if you look at, Mario's not here tonight, of course he's he's out watching the eclipse, or preparing for the eclipse. But if you look at some of his images, they're pretty deep, and almost every one of his images, you can find faint little galaxies that they're sprinkled everywhere across the sky. And so I'm not surprised that there's one nearby, but if you're hard pressed to find 30 hours of imaging, you're not going to see that with a visual telescope, but you can try, but it's going to be tough. Anyway, go check that double star out. It's a lot of fun. And so here's the Observer's Challenge for the month. I'll let you do this, Clint.
Okay, this is a beauty, NGC 7027. It's a planetary nebula, and it's not that much observed, and I think one of the main reasons is it's in a kind of a star-packed part of the sky. You're in the Milky Way right here, so it's a little hard to find. If this object were right near a bright star, for instance, or between stars like M57 is, it'd be a lot easier to find it, but I had no idea what this was about. I'd never seen it before, and I was absolutely stunned at how beautiful it was. It's a star hop either 2 degrees from Xi Cygni in one direction or 2 degrees from Nu, and I just had to make a chart. And for me, because I'm a star hopper, I went from Nu Cygni up to this particular object, and it jumped right out at me. I always do my star searches with low power first, and it's just this deep, vivid blue star. And I think we'll go to the next slide. I've got a sketch that I made a little later on. We'll go to the next slide. These are some of the images. This is by Doug Paul. Doug is here, so you can give us the specs on this.
Well, that's a very bright, very small object. That's about a half hour of total data, but my individual exposures were 4 stops shorter than normal. And because it's so small, it's also blown up by 300%, so it's a little extra blurry.
Those of you who look at a lot of planetary nebulas, this particular one is about the same brightness as the Saturn Nebula, NGC 7009, but it's about half the size. This is something like 12 by 18 arc seconds, so you do need a fair amount of magnification to start to bring this up. But usually I'll take an O3 filter and just put it in front of the eyepiece because the O3 filter will bring out planetary nebulas a lot better. I didn't need it for this. There was no doubt, even without any type of filter, that this was a planetary nebula. It's like an out of focus star, while the star is in the same field with sharp points of light. It's a beautiful object.
It's a pretty bright object. Doug, that's the true color, right?
As best I can do it.
Yeah, to me it looks blue in the eyepiece, but that's why it responds so well to an Oxy 3 filter.
A number of them look blue or green, depending on who you ask.
Yeah, But the green color comes from forbidden transitions of oxygen. And that's what the Oxy-3 filter that Glenn just mentioned has an 11 nanometer, the Lumicon version has an 11 nanometer bandpass centered on 511 nanometers, which is where the forbidden lines of oxygen occur. And so that's why they look green. The brighter ones, you can really see, some of them they're stunningly bright and beautifully colored. I mean, this is no exception. This is one you should, if you've never seen 7024, you should go out and look at it.
That was shot with a DSLR with no filters, so it's a wideband shot. And,
see this?
However realistic the color is.
See this little sort of a belt right here? I could see that the other night. I was looking at this the other night. I could actually see a hint of that. I think it's almost like a bi-lobed planetary.
Yeah, you look at the Hubble pictures, and there's a lot more structure in there that can't be solved. This is only a 6-inch aperture.
Yep.
And by the way, this is one of the most photographed and studied of all the planetary nebulas. The reason is it's fairly young. They're talking, I guess, in the order of maybe 1,000 years or less, or a few hundred years. So it's a kind of a proto-planetary nebula. And it's very small. It's about 1/10 of a light year across compared to the typical planetary nebulas, a full light year. So this is small and young and being studied very heavily. And this is Mario's picture. I don't know if Mario's on Zoom right now. We can.
I don't know.
Is he out there, Mario? You out there in Arizona?
Mexico.
He's not
Somewhere out there.
Oh, I hope he's not in Arizona. He missed the eclipse. Okay.
Here's
And
one sketch.
my sketch. This was with a 10-inch telescope. I didn't put the power down, but I think it was about 140 power, if I remember right. And again, because I don't have a clock drive, I have to keep re-aiming. And at one point, I just looked away to do some sketching. When I looked up, it had drifted out of the field, but no trouble at all. I just moved the general direction of where everything was drifting, and it just jumped right up. This beautiful, kind of slightly oval, bluish, out of focus star. So it really is a stunning object to look at.
And it's easy to find. It may.
It's a star hop.
You've got a star hop, but when you hit the field, you can't miss it. You'll see the color. You'll see that it's certainly non-stellar, and then it takes magnification really well. And I actually liked it better without filters the other night. I tried the Oxy-3 and I didn't like the look of it.
Didn't improve
So
much.
I liked it. Sometimes I use the UHC filter, but sometimes I like to see all the stars too. So I just go without filters. And this is one you can do that with. So if you've never seen 7027, go for it. Go for it. And I'll say this one other thing about planetary nebula. If you have your Oxy-3 out or a UHC filter, try the Helix Nebula. It's a great time of year to try that. It's a little bit low in the south, and it's big. It's about half the diameter of the full moon. But the Helix responds very, very well to filters because it's a relatively low surface brightness, and the filters show it particularly well. So check that one out too. 7293, the Helix Nebula.
Okay, that was our good news. This is the bad news. The November Observers Challenge, I know Rich and I have both tried this one. I tried it with a 10-inch telescope on the magnitude 5 skies, and I saw nothing.
And I tried it with a 20-inch under magnitude 4.5 skies, and I saw like pretty much nothing.
But it's right next to Beta Cas, so it's about maybe, I think it's a degree or two away from Beta Cas, so it's very easy to star hop to it. And this is Doug Paul's image. And if I remember, it's about 6 or 7 arc minutes across, which is about the size of the Dumbbell Nebula.
But the field of view there is top to bottom, that's about almost a degree.
Yeah, so I know with my field of view, I had a 1-degree view, and I keyed in on these stars. I know exactly where to look. And the star there is a star right there. It's actually a Milky Way star in the foreground. I could see that, and even knowing the size, what I was supposed to look for, I saw absolutely nothing. I tried averted vision. I waited a long time. So I think if I wanted to see this, when I go out to an area like Stellafane, where there are magnitude 6 skies, I would kind of hope you could see with a 10-inch scope with a little bit of patience, but you're going to need dark skies.
It's an irregular galaxy. It's a local group galaxy. It's part of the local group. And the reason it's only a couple of million light years away. You'd think it'd be brighter, but it's actually obscured by Milky Way dust.
It's also obscured by a lot of stars. I use star suppression in
Really?
making that
Okay.
image.
Glenn's right. This little group here of stars and this triangle, this is how I knew I was on the field.
Yeah.
Oh,
You know?
that blue star down to.
This one here?
To the right, yeah, that's
Yep,
that's very.
I came in this way
pretty
here.
Yeah,
As soon as I found that triangle, and then I saw these guys, I'm like, okay, I'm on it. And there might have been a hint of brightening, you know, I've said it before, the quote is sometimes attributed to Michael Covington. You should spend at least 15 minutes on a galaxy, on every one of them you observe. Your eye will start to pick up those photons, and all of a sudden you might start to pick it up and start to actually see it. After a half an hour, I could see nothing.
That's
and-
only about 4 hours.
4 hours, right? And Roger Iverser had similar luck. He's got skies that are a little bit darker. Using a 10-inch scope, he could just see a hint of brightening where it's supposed to be. So, dark skies. Onward.
I think that's it.
Onward. So here they are. NGC 7027 gets 3 stars from Keppel and Sanders. I think that's who it is. They don't even list IC10, the local blue galaxy in Cassiopeia. But the December challenge is IC 1848, the Sol Nebula. Now 1848 is the designation that goes for an open cluster and the nebulosity that surrounds it. I've tried to see the Sol Nebula before. I've never seen it. If you're ever up at the clubhouse and Slav is up there with his night vision thing with the H-alpha filter, ask him if you can look at the Sol Nebula with that, because it just leaps out of the sky at you when you've got an image intensifier going.
Naked eye, no magnification.
Naked eye, no magnification. Just hold it up to your eye and go, oh, look at that.
Yeah, it's big.
It's pretty big. It's very challenging. The nebulosity gets the 1 star. The cluster got 3 stars.
It images nicely, but you'll have to wait for that.
Yeah, it does, yeah.
So with that, I'd like to introduce our guest speakers, Qijia Zhou and Kane Sjoberg. Sorry, I've got my bar covering stuff. And they'll talk about the NASA Eclipse Ambassador Program. Qijia Zhou is a senior undergraduate here at Harvard College, concentrating in physics and astrophysics. She is collaborating with Mario Motta, who unfortunately can't be here. I know he wanted to be here. We were originally going to have her talk a brief bit in November, but we have her talk now. Mario's out traveling to New Mexico for the eclipse. I know he wanted to be here. But they've been working together on the Eclipse Ambassador Program, where they aim to bring eclipse education to the Boston area. She'll be talking about the upcoming solar eclipses in October, just 2 days from now, and April, the full total, including eclipse science, observing safety, viewing locations nearby, and Harvard's eclipse outreach events. Qijia will be joined by Kane Sjoberg, a junior at Harvard studying astrophysics. Kane is the president of the Student-Astronomers at Harvard-Radcliffe, abbreviated to STAHR. He helps run the open houses at STAHR's Loomis-Michael Observatory and enjoys teaching telescope and astrophotography classes to students. So please welcome the guests up.
Awesome. Yeah, again, thank you guys so much for having us here today. Again, we can just start by introducing ourselves really quickly. So I'm Qijia, and I'm a senior here at Harvard, hopefully graduating this year with a degree in physics and astrophysics, and I'm planning to apply to the PhD program. So again, hopefully I'll still be around as a grad student in astrophysics. I've done some research here at the CFA, specifically in exoplanets. I've actually worked with some of the same professors that Mario worked with on some of his papers, which is super cool, as well as some laboratory work, and more recently some instrumentation. So again, be happy to talk about that after if you have some time. And yeah, real quickly about the NASA Eclipse Ambassador Program. So again, that's sort of like how I'm partnered with Dr. Motta. So there's a program that's sort of run by NASA and the Astronomical Society of Pacific, and it partners amateur astronomers and undergraduate students all across the country to sort of do these like eclipse outreach events, especially off the path of totality. So people, even if they're not in the path of totality, will have some idea of like what the eclipses, what the upcoming eclipses will look like, and the science behind it, and some like observing safety. And again, if any of you guys are interested in applying to become an ambassador, they're still taking applications, so I think a lot of the focus is going to be on the April eclipse. So yeah, feel free to ask me about that if anyone's interested.
Hey, I'm Kane. I'm a junior at the college studying astrophysics and physics. This semester I'm doing instrumentation research with the COVAC group. So they work on cosmic microwave background observations, specifically polarization of the beta mode radiation. I'm the president of Student-Astronomers at Harvard-Radcliffe, or STAHR, aptly named. We care for the Loomis-Michael Observatory. This is on the 9th floor of the Science Center over in the plaza. It was inaugurated on March 5th, 1976, and it's a 2-ton f/15 10-inch aperture refractor, and we love it very dearly. And so we're responsible basically for all things amateur astronomy and hobbyist interests. We run open houses and things like this, and we grant students access to the observatory for their use during their time here. So these are just a few pictures I've taken with Loomis-Michael, which is the DSLR. So you have Venus, Jupiter, Saturn, Uranus, and Neptune, which I managed to find with those, and so I just thought they'd be fun to include. So yeah.
Okay, yeah, so again, here's sort of like the main event that we want to talk about. So there's like a double header eclipse, again, one that's coming up in 2 days, and of course I think the more exciting one that's coming up in April next year. And here's sort of like just a map of like where the path of totality will sort of sweep across the United States. So again, Mario's very, very lucky. He's in New Mexico right now to see the annular eclipse. I think he'll be able to see the ring of fire and send pictures. But again, with the total solar eclipse, that path of totality comes much closer to home. So maybe some of us will be able to observe that as well. Okay. Again, I feel like you guys are very like astronomically knowledgeable, so this might be a lot of review, but I thought I'd start off with just an overview. And if anybody doesn't know about how these solar eclipses form, so again, it just has to do with the geometry of the sun, earth, and the moon. And a solar eclipse just happens when the moon passes between the earth and the sun. And something that I thought was really cool is that there's sort of these 2 shadows that are formed by the moon. Again, there's the umbra, so that's a full shadow. If you're on the earth in that sort of umbra, full shadow region, that's when the moon fully covers up the sun. So, and you'll either see a total eclipse or an annular eclipse. Again, we can get into details in a second, if you're in that sort of very, very narrow, small region. But then there's a much larger shadow called the penumbra of the moon, and that's where you'll see a partial eclipse. So again, that usually covers a much larger region of the earth, and that region will see a partial eclipse. So again, that path of totality is super narrow, and it's pretty hard to try to get to see that 100% eclipse because that the moon shadow ends up getting really, really like tiny once it gets to the earth. But again, I heard it's a very, very cool experience if you guys are able to go. All right. And again, just going over the couple different types of eclipses. So yeah, we talked about the partial eclipse. So that's just when you're in sort of like that partial shadow of the moon. And total eclipse, which is what's going to happen in April, is when the sun is like fully covered up by the moon. So again, the moon moves in an elliptical orbit around the earth. So the distance between the earth and the moon will change like throughout its orbit. So sometimes if the moon is slightly closer to the earth, it will appear bigger in the sky. So then it'll be big enough from our point of view on earth to cover up all of the sun. But if the moon is slightly further away, like in the second picture, then you'll get an annular eclipse. So the moon will be slightly further away, will look slightly smaller in the sky from our point of view, and then it'll only cover up most of the sun's surface, but then it'll leave that little sort of like edge, that ring of fire from the sun's surface around the edge. Yeah, so those are just sort of the 3 types of eclipses you can see. Again, annular is what's coming up in 2 days, though we'll just see the partial in Boston, and then total in April. Of course, I got a lot of lovely images from Mario for these different types of eclipses, because I think he's probably seen it all. So again, there's a really lovely photo of a total eclipse. Again, the really special thing about total eclipses is that when the moon is able to fully cover the sun's surface, you actually get to see the sun's atmosphere, so the corona. And that's because normally the sun is just like, the surface is so bright that you can't see any of the atmosphere. It's very dim compared to the surface of the sun. But then once the moon covers it up, you'll be able to see that sort of like bright, again, halo around the sun. And here's a nice picture of the annular eclipse. So you can see that the surface of the sun is still sort of visible around the shadow of the moon. And then the partial eclipse, again, yeah, it looks like it's just like had a bite taken out of it. All right.
Okay, so I'll just be presenting a few details about what we have coming up in 2 days. So yeah, the path of, well, semi-totality is not really coming very near to us. Those who are in like Texas, New Mexico, Utah, they're very lucky. We're gonna get about roughly between about 20%-ish illumination over here, which will still be pretty significant. The sun will look unusual, so yeah. And so yeah, max coverage is going to be 29%. It's going to last for a few hours. So first coverage contact happens at 12:18. The max coverage will occur at about 1:30. That won't last too long, and then the eclipse will end at 2:30. And the weather forecast is looking iffy, as is natural for Cambridge. I think a definition of optimism is being an astronomer in Cambridge.
Good for you guys.
Yeah. So hopefully, we'll get lucky, and maybe we'll catch a few glimpses if the clouds are well formed. So.
Okay. Yeah. So we'll talk a little bit about the April 8th total eclipse. Again, here's like a pretty detailed map of the path of annularity, and it does take us pretty close to Boston. But we might give you guys some reasons to travel to the path of totality. So one thing that I've been told, so I or Kane, I think we've never actually been to a total solar eclipse, unfortunately. We hope we will be able to at some point. But from all of my friends who have either been to like the 2017 eclipse or other eclipses, like Mario, they really want to emphasize that 99% is not at all the same as 100%. So being in the path of totality versus being just slightly out of the path is very, very different. So all these really nice photos of 99% versus 100%. So with 99%, you still have to wear eye protection the whole time. Again, since like part of the sun's surface is still visible. Again, you'll get to see like most of the sun's surface covered up and just get that tiny sliver, but you won't see the corona. So that like nice atmosphere around the sun, it's only visible if the moon is fully covering the sun's surface. So again, if you guys have the opportunity to travel to the path of totality in April, we definitely recommend it. We'll be trying to do the same thing. Because even though it's 93% in Boston, again, you'll get to see a really nice view. This 100% totality, again, just has a whole different environment. It's really, really special. Yeah, I think that's one of the common misconceptions. All right, here's sort of like the cloud forecast that's based on, I think, statistics going back to around 2000. So again, you can see the path of totality across the US. And then on like a color scale is the sort of like median cloud amount. So how many days, out of 100, you'll probably have clouds on. So as you can see, again, sadly, around like Boston, New York area, we'll probably have a pretty, good chance of having clouds in that day. But if you were able to travel a little bit down south, maybe Texas, Arkansas, that region is probably less likely to be cloudy on those days. So again, these sort of maps can sort of help you plan your travel and see, again, where you might get the highest likelihood of seeing the eclipse. And here's another, I think, helpful plot. So basically this is just like a cross section. So if this line is tracing across the sort of central line of totality, and it's also basically telling you like what the cloud fraction is based on some like historical data. So the red circle is sort of where we would be if you go up to like upstate New York, Buffalo, Rochester, and you get pretty high cloud fractions. But if you go down to Texas or even Mexico, then you'll probably get pretty clear skies. Yeah, and this is what I've heard from, again, my friends who have been to the 2017 eclipse. They said to really, really try to plan ahead. So this is probably why we're chatting about this even in October. So I've heard the roads get very, very packed. Again, people all try to like swarm to the path of totality once they hear that there's a total eclipse happening. So I'm pretty sure Mario plans his trips like months in advance. So you definitely talk years. Well, yeah, there you go. So, it's very nice to try to book, try to get there ahead of time. I'm sure he was in New Mexico for a few days now to set up. So yeah, if you're able to, make sure to plan to travel.
Yeah, so I just want to present some resources for the eclipse planning. So as far as weather conditions, specifically for these astronomical events, eclipsophile.com has a lot of great data on there for different locations. For just general observing conditions, I love to use cleardarksky.com. I use this back in California, where I'm from, and it works really well here for predicting what clouds are going to be like, and especially the transparency and seeing forecasts are super useful, especially for planetary imaging. Of course, it doesn't apply for necessarily the day, but just as a general resource, if by some chance you have stumbled upon this, I really would highly recommend this. And then so timeanddate.com has a lot of useful statistics about the exact timing if you wanted to plan a trip or something of the sort. And then if you want to learn more about the eclipses, science.nasa.gov has a lot of awesome information.
Yeah, I think what's nice about time and date as well, they tell you the altitude of the sun. So if the sun's going to be sort of lower on the sky or higher, you can sort of plan for that and sort of know where to look and know if you need sort of a flat area to observe.
Yeah, so these are a few locations nearby it's just basically a close-up of the path of totality. So if you wanted to make some plans about where to go, these are some potential locations nearby. Going back to the graph we saw previously with the average median cloud forecasting, it may be possible, depending on how dedicated you are, also with your wallet in hand, that you'd want to go somewhere entirely different, further south. But if you're looking for a more local get out, because maybe you've seen it before, these are some of the local places nearby. So.
All right. I don't think you can really read this map, but again, I think you can find it online, but there's actually some maps that tell you how long the eclipses will be in different parts. So that red, sort of the thicker red lines trace out the path of totality, but if you kind of get more central in the path of totality, the eclipse will be longer. So I think there's a maximum of 4 minutes if you're really central in that path. But as you go out towards the edges, the sort of time that the total eclipse is actually fully a total eclipse gets shorter, around 2 minutes around the edges. So again, if you're hoping for a longer eclipse, a longer sort of period of time to be able to take those nice images, if you can make it to those really central regions, it does make a little bit of a difference.
Yeah, so now for kind of the big exciting one that'll be passing conveniently very nearby us, we're going to get 93% maximum coverage here, which is, it's not 100%, but you know what, that's still pretty good. It's going to look pretty interesting, very Lord of the Rings-esque, maybe Mordor. And so we're going to get first contact at 2:16. The maximum coverage is going to be happening at 3:30, and then it's going to end at 4:40. So a lot of really good time that gives us at least see something interesting. This includes, even if we do get some clouds, potentially we'll get a lot of good glimpses on the way throughout. I also just wanted to share that STAHR, in collaboration with the Society of Physics students at the college and also the Astronomy Society, will be hosting a public event on the Science Center Plaza here. So where that tent is, we're going to have a heliostat tracking and set up to do some projection of the eclipse. We'll have several telescopes set up, including hydrogen alpha telescopes. We'll have demo stations, eclipse glasses galore, of course, and it'll be a public event. So if you know people who are interested, and if you just want to come by, or even better, if you have your own telescope you want to set up and also help contribute to this, we would love to see you there. So yeah, rain, and then rain or shine, Cambridge being Cambridge in the spring, we'll have live stream projection, and there'll be food and drinks. So yeah.
But again, totally don't blame you if you want to flee south and go see the actual total eclipse.
Indeed.
All right.
So yeah, the next total eclipse in the continental US will be in 2045. So that's a pretty big impetus to go find the path of totality. That's not to say you can't find total eclipses well before then, because of course it'll be crisscrossing the globe every, definitely at least within every decade. And so there'll be many chances, but again, if you want to stay within the US, 2045 is the time. So this is a pretty special event.
All right, of course, the fun stuff, the eclipse viewing safety. So I think the sort of rule of thumb, the best rule of thumb is that if there's any part of the sun's surface that's visible, then you should be wearing some sort of eye protection or having protection, a filter on your telescope. Because and it's really, really not good for your eyes to look directly at the sun, especially when it's eclipsing. Even if you have like a 95% eclipse, 99% eclipse, if any part of the sun's surface is still showing, there's still a lot of radiation, a lot of photons. And especially if it gets like pretty dark, your eyes will start to dilate because it doesn't know that you're still getting that radiation from the sun, and then you'll get, you have more like risk of having some like eye damage. So again, the only part of an eclipse that's really safe to look at without any filters or protection is during the total eclipse. So if you're in the path of totality, during a total eclipse, the moon is covering the whole sun, like none of the sun's surface is covered. That's the only time you should really be taking your glasses off. And actually, you should definitely take your glasses off if you're seeing this total eclipse, because it's much dimmer than the sun is normally, so you wouldn't be able to see anything if you had your glasses on. But again, yeah, just a good rule of thumb. Again, if you have any family members, especially like tell your kids if they're watching, keep those glasses on until the moon fully covers the sun. All right. And again, this sort of applies for the annular eclipse. So again, annular eclipses, unfortunately, you can't take your glasses off during any part of the eclipse, since a bit of the sun's surface will always be showing during the entire duration. And again, here's actually really just a slide to sort of feature some more of Mario's really nice images of what the corona would look like, again, with just the naked eye during a total eclipse.
Excuse me, that's not what you'll see with the naked eye. Those are high dynamic range compressed images, so you won't see that much ray structure with the naked eye.
Oh, sorry, I apologize. Sorry, without like protection. Yeah, without the glasses. You're right.
They are still pretty obvious.
Yeah, we can definitely still.
You can see them sprawling up. It's incredible.
And if you use a telescope during totality, you'll see the prominences, you'll see other features near the sun.
Yeah, Mario sent me a bunch of pictures. I'll go through a timeline he put together of like all the different like stages of the eclipse in a second. So he has a lot of very nice images from that. All right, yeah. All right, and then and here's just a really nice link if you're looking for like places to purchase like glasses or filters. Again, I know there's some concerns. There's some concerns in 2017 eclipse about like fake filters or viewers that weren't up to standard. So there's an international standard that all filters should like meet. And then the AAS website has like a list of all like their sort of approved vendors and places to get them. So Mario wanted me to include a slide about unsafe viewing methods that maybe he has seen people do or heard of. So, again, of course, please don't look at eclipses with your naked eye. That's, again, unless it's during totality. Any other time, it's very, very, very dangerous for your eyes. And again, sunglasses, multiple sunglasses, that it doesn't help. It's not, again, it just doesn't filter enough light through. And then, again, there's a couple other, I'm not sure, I haven't even heard of these methods.
I'm kind of impressed by some of these, I gotta say. Like, this is creative.
So none of these are really like safe viewing methods. Really, the only sort of safe option is like those approved like eclipse viewers. And yeah, something that I didn't know actually before this is that even if you're wearing like eclipse glasses or like having or you have an eclipse viewer, if you look into a telescope, it's still not safe because those telescopes, again, I'm sure you guys all know about this, but they like concentrate the rays, and it's, even if you have those glasses on, you need a filter on the telescope in order to be safe.
Yeah.
Yeah, so just some of the safety tips around like the AAS website, and you shouldn't be able to see anything through the glasses except for the sun, because these filters should be really, really dark. Again, make sure to check that your filters are not punctured, scratched, or torn, so if you're using filters from previous eclipse. And then there's also some eclipse viewers that say that they're you can't look through them for more than 3 minutes at a time, or you should discard them if they're more than 3 years old. So if they meet this like ISO standard, those warnings are outdated. So the American Astronomical Society has said that you can still use them in case you have some of these around your house. But I think most of the newer ones shouldn't have these warnings.
Yeah, so I just wanted to present some information about like safe viewing through a telescope, and then also just ways in which you can view the solar eclipse with a telescope. So among the most straightforward are just the conventional white light solar filters. So for a lot of your telescopes, including Schmidt-Cassegrains, the manufacturers like Celestron and so forth, they make visual broadband viewing white light filters that just reduce the overall flux intensity down to a really palatable level for your eye. And in white light, so you'll be able to see the photosphere and the sunspots associated with that. That's the particular type of detail that you'll be able to resolve. More exciting perhaps, also more expensive, are hydrogen alpha telescopes. And so these are dedicated narrowband filters that allow you to see the chromosphere, which is actually above the photosphere, but it's less hot and it's translucent in most optical wavelengths, generally speaking. It's also just outshone by the photosphere. And so if you're looking with an H-alpha telescope, you'll be able to see more of the chromosphere, which reveals things like flares, prominences, and general the active solar surface. And of course, the good old low-cost method is a pinhole camera. This is always an option. And yeah, I don't really use unfiltered telescopes or try to look through with eclipse glasses. I also didn't know about this as well. And so as far as solar filters and imaging in more detail, I wanted to present about like some of the ways in which you can actually start to like image and also just view either eclipses and or the sun in general. So again, with the white light filters, these are available for reflectors and refractors, camera lenses. They're pretty common. You can get, there's two types. You have film and glass. Film are more prone to like ripping and pinholes, which can selectively blow out portions of your retina. And glass in general is more consistent. And I think there's also a difference that some have written on like Cloudy Nights about basically a difference in terms of color. So with film, you'll get kind of a white light view, whereas with glass, I think you get more of like an orangish view. So it's kind of more your personal preference for how you're viewing this. And then when it comes to narrowband imaging and viewing with telescopes, you get awesome views of solar prominences, active regions, and surface detail. And so there's a few methodologies employed with this. Generally speaking, the name of the game comes with etalons. And so I've included kind of a diagram that describes how this works up here. And so what the etalon does is it's basically two precisely parallel planes of glass that are semi-coated with a coating. And what happens is by very, very precisely spacing the two pieces of glass apart, you get an interference effect and also a destructive interference effect, both constructive and destructive. And so what you get out on the other side of that etalon is basically a comb tooth appearance. You kind of discretize the wavelength, broadly speaking. And so these can be tuned for the hydrogen alpha basically peak. And then what you'll have is basically an etalon on the front, and then you'll have a blocking filter, which just isolates the other combs and removes those. So now you're just looking at, well, the one particular peak associated with the hydrogen alpha wavelength or the calcium K with narrowband wavelength. There's a few available. Manufacturers like Lunt Solar Systems produce all these, and they produce them in both a modular form for their specialized telescopes where you can actually insert and remove different etalons. And you can also just get kind of front-mounted etalons that go on your conventional nighttime refractors. Generally speaking, it's pretty cost intensive to produce large etalons, and so you'll tend to see these on like under 100 millimeter size refractors. Pretty rare to see it for reflectors. It's very expensive, and also refractors can kind of handle this better than reflectors can. You'll get some light like tube currents that are occurring when you're using refractors generally, but overall it's not too bad. And if you further want to like protect your system, and if especially for larger aperture systems, like if you're using a 120 millimeter refractor, for example, you'd want to maybe consider getting a blocking, not a blocking filter, a energy reduction filter. And so this is kind of a UV IR blocker that goes in front of the etalon. And so that just kind of again reduces and takes out a lot of the heat intensity that your telescope will be receiving. So a full setup, if you were really invested, would be like an energy reduction filter, then an etalon, and then in the back near to the eyepiece a blocking filter, and the blocking filter will bring down their overall intensity usually, in addition to kind of also further isolating that hydrogen alpha wavelength to really get you a very like contrasty view of the sun. Other options include double stacking, so you can also actually put like two etalons on top, and that further reduces the overall bandpass from maybe around 0.7 angstroms down to 0.55, and so that gets you some extremely contrasty images. There's a few different types of etalons. There are airspace etalons, which use pressure tuning because you have to really, really precisely calibrate the spacing depending on where you're observing from, your elevation, and also the angle of the sun. And then there's also there's etalons that are spaced through with a certain material that they actually use heating for to basically change the effective distance. And so you have a lot of options. You can get like dedicated modular mounts from, like I said, manufacturer like Lunt, and you can also just buy basically etalons that go pop onto the front of your refractor. So I don't personally own one of these, but I would love to. I really want to get more into like the solar imaging scene. So yeah.
Yeah, as you can see, Kane is really the astrophotography expert here, so feel free to ask him more questions about like solar filter. Oh,
Yeah.
I would really like to capture a flash spectrum, and I wonder if you've spoken with anybody who's successfully done that, and if you have any pointers.
I capture what, sorry?
A flash spectrum?
I don't think I know what that is.
So it's just as, right at the point where you see Bailey's beads,
Okay.
if you have a diffraction gradient
Okay.
on the scope,
Yeah.
basically you're seeing the emission lines in the corona instead of
Oh,
the
fascinating.
absorption.
Wow. Okay, so you can actually separate.
Right,
Yeah.
so what you'll see is you'll see like a stripe of little slivers,
Sure.
you know, in all the emission.
That's really interesting. No, yeah, I haven't really spoken to anyone about solar daytime astrophotography. My background's more nighttime, but I really want to learn more about it. I didn't know that. That's
You can only catch it like right at first, you know, right at the beginning or the end of
yeah.
your full contact. That's called.
That's
The
fascinating.
moon basically acts as your first slit
Yeah.
in the spectrograph, and then you get a number of curved lines at the different wavelengths.
Wow.
That's very cool.
Yeah. And of course, there are indirect viewing methods. Kind of everything starts to produce the eclipse if you look carefully enough, which is really cool and really fun. So that's something I'm very excited to see with like trees producing this. And so yeah, again, also if you want to do a pinhole camera, that's another option. Yeah.
I think my favorite is the colander example. Yeah, like again, everyday household items can be used to see the eclipse as well. Okay. All right, so here's a few slides from Mario. I'm sure he would have loved to present them in person, but I'll try to present them in his stead. So again, he's created sort of a timeline for things to look for, including Bailey's beads and sort of like the diamond ring effect during a total eclipse. And again, he's been to 15 eclipses, and this will be 16, again, if he gets to see the annular eclipse in New Mexico. So first, we start with first contact. So first contact is when the edge of the moon starts to eat at the edge of the sun. And again, this is when he usually like sets up his mount tracking and alignment and checks his filters and everything. And you can watch for sunspots. And here again is a really nice picture of just when the moon is starting to cover up the sun from the eclipse he saw in 2001. Okay. So that will probably go for a while. And then I think the next stage that he pointed out is around a minute before second contact. So again, second contact is when the edge of the moon sort of hits the other edge of the sun, and that's second contact is when totality starts. So I think this is when you can sort of see the really cool like environmental effects as like the sun's surface gets covered up. So again, here's a really nice picture of this like twilight, atmosphere that starts to appear as the moon covers up the sun. And then around 30 seconds before second contact, you get Bailey's beads. So again, like you guys mentioned before, as the moon just like almost like finishes covering up the sun, and there's some like texture on the moon, of course, from like little like mountains and valleys on the moon's surface. So then when you're just getting like those last rays of sun coming through, they'll sort of like filter through unevenly, and then those valleys will sort of act as a slit, and then you'll get these like sort of like bright patches that are like Bailey's beads right at the edge of the moon's shadow. And then just in those very last seconds, I've heard this is like a very, very short sort of transient effect once you get to the last Bailey's bead. So again, that just last bit of light coming through the edge of the moon's shadow, you get that really beautiful diamond ring effect. So, and Maria's lucky enough to have 2 different pictures, probably a few more, of the diamond ring, just in those last seconds before totality begins. So again, if you're able to capture that, this is extremely beautiful, really stunning images. And then, yeah, so second contact is when that moon's edge sort of finally covers up that last bit of the sun's surface. And this is when totality begins. So again, you can take filters off, you can take your eye protection glasses off during totality, and get these really nice images of the corona, and sort of you can experience totality fully. So again, here's a really nice collection of images from all the different eclipses that Mario's been to. Again, you can see that the corona looks different in all of these different eclipses. So it kind of just depends on the magnetic activity of the sun and like what sort of cycle it's in at that time. So, and if you're lucky enough to see multiple eclipses, you can see again, all the sort of differences in the corona. Yeah, I think you guys mentioned like prominences. So yeah, sometimes, again, if the sun's really active, you can see those little like sort of red splotches in the corona. So that's another thing you can sort of view during those few minutes of totality. Yeah, you just really want to emphasize the experience is really, really just something really special. Again, where it feels like twilight, you can feel the temperature drop a little bit as the sun gets covered up. And there are animals, like if there's any animals around, if you're in a national park, you'll sort of like hear the birds flocking and sort of all the animals like going to go sleep because they think that the day's over. But then, of course, when totality ends, they're all very confused and, you know, pick back up. So third contact is when the other edge of the moon starts moving off the sun, and basically the sun sort of starts to reappear again. So again, you get all of those different stages, but in reverse. So you get that first diamond ring as the sun sort of, the rays start coming out from the edge of the moon's shadows, Bailey's beads, and make sure to put all the filters, eye protection back on as the moon starts moving off of the sun. And again, yeah, you get to capture basically everything, but in reverse. All right, yeah, and that's it. So that's, I hope this has been helpful or like a little informative. And again, feel free to contact Mario again if you have any like sort of specific solar observing questions, since he's probably the expert here. Yeah. Any questions? Thank you. Yeah, again, this is a really cool image, I think, that Mario put together too, where it's showing all the different stages of an annular eclipse. All right, well, if we have a little bit of time, maybe Kane can just quickly talk about STAHR.
Yeah, I'll just briefly introduce it. I mean, so STAHR has been around since, well, basically 1976, when the observatory was formally commissioned. We've had a few interesting things happen in our history. Neil deGrasse Tyson came through and was one of our alumni who used the telescope. We also in the 1990s had the dome blow off into the law school yard, and now it's a steel dome as opposed to a plexiglass dome with a strict limit of 25 miles per hour. But no, in all seriousness, what we do is we support amateur astronomy across the campus. So we run several different types of programs that try to cater to students' different like niches and interests. So we run astrophotography classes, which I help teach. We also have general telescope classes, which allow students to use the Loomis-Michael Observatory. It's a 2-ton equatorial mounted telescope, and the motor gear system is actually surprisingly accurate. Like you can look at Jupiter for a few hours and it'll remain in field of view at like 3,000, 4,000 millimeters. It's a really beautiful piece of machinery. And so we run all sorts of different events. We run open houses, generally in the evenings, where you do kind of the things you do at STAR parties. You know, you get like Saturn, you get Jupiter, and so forth, the moon. We also do like the 4:30 a.m. like blood moon of observation, among other things. We do all sorts of events here. We also, kind of our specialty that we do is dark sky trips. So basically about twice a semester, we take between 25 and 30 students out to Cape Cod to do a night of observing. We get like a fire permit, and we set up a little campfire on the beach, and we have some like astronomy interpretation happening, and a few telescopes set up in the parking lot. So we have like a 10-inch Dobsonian from Celestron, and then we have we have an 8-inch SCT, and then a few smaller telescopes. So yeah, that's what STAHR does, and I just wanted to share with you guys about this. And if you're interested, please reach out to me. My email is Kane Sjoberg at college.harvard.edu, and we can add you to our mailing list if you'd like, where you can come by and see Loomis-Michael during our open house events. So, yeah.
Very cool.
Yeah, that's it. Yeah, thank you guys so much for having us here. And we really appreciate you guys like welcoming us into your meeting, and thank you all.
Thanks so much.
Thank you both. That was a fantastic overview, especially, I know this year we've had a lot of new members join, and that kind of all-encompassing resource could be very helpful to them, for sure. So thank you very much. So with that, I will officially close the meeting. So this is the date for next meeting and the upcoming board meeting. And again, all members are welcome to join the Zoom and listen in on the meeting, hear what's going on. So thank you all. There's refreshments in the back.